friends, today we are going to learn about filters. So in this section we are going to learn or we are going to cover these points. So first is a introduction to filter, types of filter, frequency response of filters, and next is a filter characteristics terms. So basically filter means what? Right. So as you know, this is one of the frequency selective circuit. This is one of the frequency selective circuit. Means what? It will select the certain frequency. It will select the certain frequency, or it will select the certain band of frequencies and reject the remaining band of frequencies. Right? It will select. It will pass. Right? It will select or it will pass a specific band of frequency, a certain band of frequency, and it will reject or attenuate, right, the remaining band of frequencies, right? So that is called as an filter, right? So these filters are classified into two types, basically digital and analog. Digital and analog. Analog filter are again classified into two types, passive filter and active filter. Alright. So passive filter means what? This is a passive filter where the passive components are used. The passive components, nothing but resistor, inductor and capacitors, are used in this passive filter. Alright. See, in this passive filter, means what? Passive filter don't use any active component or active devices. It don't use any active component or active devices. It uses only RLC, that is a passive components, right? And this passive filter have a low efficiency. Passive filter have a low efficiency, and as you know, all filters having frequency response characteristics, that is a characteristics, right? So the frequency response characteristics are not very sharp in these passive filters, right? It is not sharp, where in active filter, so these are the filters where the active component or active devices are used. So active component or active devices, nothing but transistor, op-amp, right, FET, etc. So these active devices or active components are used in these active filters, right? So in addition with this active component or active device, some passive components are also used. So these passive components, which are resistor and capacitor. See, inductor is not used here. Inductor is not used here in this active filter, right? Basically, these such type of active filters are deals with low frequencies, and this passive filter deals with high frequencies, right? So active filter deals with low frequencies, right? That's why it is able to design the high order filters, right? Means what? These active filters are used to design high order filter, right? Next important thing is, in an active filter or active filter, it provides the voltage gain. It provides the voltage gain where the passive filters can't provide voltage gain, right? Passive filters can't provide voltage gain. So these active filters are deals with the low frequencies, right? And it also provides the voltage gain. That's why, right, active filters have a more sharp frequency response. That's why active filters have more sharp frequency response characteristics, and it's have many other advantages over the passive filters, right? It is having sharp frequency response characteristics, right? Having various advantages of this active filter over these passive filters, right? So where these filters are used, that is the application of filters, right? So in radio receiver, right, we have seen radio receiver where a certain band of frequency is selected and remaining band of frequency is rejected or blocked or attenuated in radio receiver. That is the function of filter in radio receiver. Right, we select 98.3 FM gold like this in radio receiver. Right, so this 98.3 band is selected and remaining band is rejected or blocked or attenuated by the filter. So this is the function of this filter. Again, this filter is used in various DC power supplies. Right, so to reduce or to avoid the ripple factors in power supplies, filters are used. Right, it is also used in audio systems. It is also used in music system, home theaters. Right, where in our home we use the various music systems, home theaters, right, etc., where the low frequency is passed somewhere, medium frequency is passed somewhere, and high frequency is passed somewhere. Right, so in these audio filters, in these audio systems, the filters are used. Next, analog to digital converter. Right, in this analog to digital converter, the filters are used to reduce the effect of aliasing, to avoid the effect of aliasing. Right, so this is the types of filter. So next is a again next is a filter classification based on frequency responses. Right, so this is the classification of filter which is based on frequency response. Right, so these are the classification. Number one is a low pass filter, which is also called as an LPF. High pass filter, that is a HPF. Band pass filter, BPF. Band stop or band reject filter, and one of the filter which is not mentioned here, that is called as an all pass filter. Right, so this is the types of filter which is based on frequency response. So exactly frequency response means what? Right, frequency response means what? So here is the frequency response. Alright, so frequency response is nothing but it explains, right, how filter behaves, alright. So behavior of the filter can be explained with the help of frequency response. In the next video we will see the various frequency responses for the all these filters. That frequency response might be for ideal or practical, we will see in the next video. Right, so here the frequency response, it gives the behavior of the filter, that is what, how filter behaves, that is can be explained with the help of frequency response. So this frequency response is nothing but basically it is a graph between the filter gain V0 by Vin on y-axis and the frequency on x-axis. So this frequency is represented in log form on the x-axis to show the large frequency bands. Alright, to know the frequency response of for all these filters, few of the terms are very important. Right, so that terms are here, that is called as an filter characteristics term. Right, to know the frequency response, so these terms are very important. If your concept of all these terms are clear, then the frequency response of all these filters will be clear. Right, so we'll see one by one that terms. Number one is a center frequency. Next is minus 3 dB frequency, Q factor, bandwidth, pass band and stop band. Alright, so first is a center frequency. Center frequency means what? So here in this diagram we have shown FC, that is a center frequency. Higher frequency FH and lower frequency FN. That is also called as an upper frequency, lower frequency, center frequency FC. So this center frequency means what? Basically this center frequency or this term is used for band pass filter and notch filter. Right, so this center frequency is used for band pass filter and notch filter. We will see in the next video. Right, so Basically, what do you mean by the center frequency? That is what? It is the center frequency that lies between the upper and lower cutoff frequency. Right? It is the center frequency that lies between the upper and lower cutoff frequency. Right? It's called as a center frequency, FC. Next is a minus 3 dB frequency. So here is a minus 3 dB frequency. Means what? Right. So this minus 3 dB frequency also called as cutoff frequency. This is also called as an cutoff frequency. Right. So cutoff frequency means what? Cutoff frequency is the frequency. Cutoff frequency is the frequency at which the output power is reduced by 1/2. Right. So this is the cutoff frequency at which the output power is reduced by 1/2. That is called as an minus 3 dB frequency. Right. And this minus 3 dB frequency is corresponds to the input frequency that causes the output signal to drop by minus 3 dB. So that's why its name is minus 3 dB. Right. This frequency corresponds to the input frequency that causes the output signal to drop by minus 3 dB, and it is relative to the input signal also. Right. So next is a Q factor. Q factor means what? Right. This Q factor is nothing but this is also called as an quality factor. Quality factor. Right. Quality factor means what? It is defined as it is the ratio of the energy stored to the energy stored to energy dissipated in one cycle of the operation. I will repeat. Right. Q factor means what? It is the ratio of the energy stored to energy dissipated in one cycle of operation. It's called as an Q factor. So how many energy is stored and how many energy is dissipated, its ratio is called as an Q factor. But it is a per cycle. It is a per cycle or one cycle. Right. The most important thing is that if the value of this Q is high, that is what? Higher the value of Q, smaller the bandwidth. Smaller the bandwidth. If the Q is high, bandwidth is low. And higher the value of Q, right? Higher the value of Q, sharper the frequency response. Frequency response will be more sharp. Right? If the value of Q is high. Right? So next is bandwidth. Bandwidth, as you know, bandwidth is what? That is the difference between the two cutoff frequencies. That is a higher frequencies and lower frequencies. Difference between the two cutoff frequencies FH and FL is called as an bandwidth. That is, bandwidth is equal to, we can say, FH minus FL, higher frequency minus lower frequency. Next is a pass band and stop band. Pass band and stop band. So pass band and stop band means what? So here is one of the important relationship between the frequency Q, between the center frequency and Q and the bandwidth. Right. So this relation is given by, see, the relationship between center frequency Q and bandwidth is what? Q is equal to FC by B. That is a bandwidth. Right. So this is the relation between this Q, center frequency, and bandwidth. So next is a pass band and stop band. So what do you mean by pass band and stop band? See, here is one diagram which shows this is a pass band and this is the stop band. So So this is the y-axis which shows the gain, x-axis which shows the frequency. So this is the band. It is the band, or it is the range of frequencies. It is the range of frequencies from this 0 to this. So this is the range of frequencies which are allowed to pass to the output. So this is the range of frequencies which are allowed to pass to the output without any attenuation is called as an pass band, right? And this is the stop band, right? So this is FC, center frequency, right? So the frequency below this FC, all this frequency will get passed to the output and the remaining frequency will get blocked or attenuated. Same, this stop band we saw, right? This is also one of the band or range of frequencies above this FC, right? Range of frequencies above this FC. So this range of frequencies which are not allowed to pass, this is the range of frequencies which are not allowed to pass to the output by the filter is called as an stop band. It's called as an stop band, right? So this is the few of the points which we have covered in this section, right? So we'll see next point in the next video. If you like my video, please subscribe my channel and press the bell icon for the next video notification. Thank you.